Good afternoon, everyone, and welcome to CFAG webinar. On behalf of CFAG, I'm delighted to welcome all our participants and speakers to this section in our seminar series on applied data science in agroforestry systems. We are excited to have such a great turnout today, and we truly appreciate you taking the time to join us. Today's section promises to be insightful as we explore practical application of data science in agriculture and forestry and other related fields. Without taking too much of your time, I'll briefly introduce our guest speaker before we begin. It's my pleasure to introduce our guest speaker, Mr. Olamide Haudu, who will be discussing on statistical analysis of environmental data. For the second section, Mr. Akinlolu will be discussing on data-driven forest reflectors, albedo. Please join me and welcome Mr. Haudu. Mr. Haudu, you are welcome.
Well, thank you very much, and thank you for the introduction. Yeah, I'll just get into it immediately, if you do not mind. Let me see, I'll share my screen now. And I have this. Okay. Yeah, you should be able to see my screen now, I suppose.
Yes.
Right? Yeah. Okay, well, thank you very much to the Center for Innovative Forestry and Agriculture for organizing this webinar. My name is Olamide Adu, and I'll be talking on the statistical analysis of environmental data. I'll just give us a brief background about myself and how I got here. Then also we'll go into environmental data properly. So about me, I'm the founder of EU Study Assist, and EU Study Assist is an organization that provide financial aid to students traveling abroad. So if you have a scholarship and you need some funds to support, yeah, you can come to EU Study Assist and we'll help with that. But not just that, we also offer training with data science skills and data science related skills, mainly the tools and how you can relate it to elevate your research, elevate your career, and also make yourself competitive for opportunities abroad. I'm a data scientist also, and I'm an educator. But yeah, that's that about me. So how did I get to be all this? Firstly, I studied forestry. Then I served as a teaching assistant in 2020. Then I did my master's. Then I went into data science consultancy. Then I founded the EU Study Assist, where we aid students, as I said, but also where we teach one-on-ones and different aspects. So if you're interested in EU Study Assists, you just do well to visit the website. Yeah. So what is this talk about? In this talk, what we are going to do is we'll go through the typical life cycle of environmental data, of course, from a statistical point of view. So we'll do some data exploration and we'll check trends, we'll check relationship. Then we'll model relationships with linear regression, but also we'll check how reliable this model is. For this talk, I've used the programming language R, but I should say that this talk is not about the programming language, but it's about the statistics and just getting a feel of how statistics is used in environmental data. Now, to environmental data properly, before we can work with editing, of course, we need to understand what environmental data are. And best way to understand this is to know their characteristics or properties. One thing is they're expensive to acquire, pretty expensive to acquire. Also, they are riddled with missing data, and they do have measurements that bias. That means you can have the same equipment that are calibrated differently, and when you use them to measure and try to get a particular variable, you get different answers. Of course, the margin might be very low. Yeah. Then there's temporal dependence, since it's dealing with the environment. Nothing is instant. There's always a time component to it, and spatial correlation, which means environment has to do with the soil or the climate, and things that are close to each other have or share the same characteristics or properties. Now, to analyzing environmental data. For this, I've picked out the data, the Ojora wildfire data set, and this data set, we have two variables that are interesting, of course. One is the occurrence of wildfire, and the other one is another variable that helps us estimate the danger of wildfire occurring. So to the variable of interest, so as for occurrence, this means if there will be a fire or if there will be no fire. While for estimating danger, that's the FWI, the Forest Weather Index. And this index just calculates the fuel moisture, that's the fuel load that is in the forest, and also check the possibility of wildfire occurring given different characteristics like temperature, relative humidity, wind speed, and precipitation, among others. Yep. Now we'll move to the data science or analysis workflow. Anytime I go into, I'm about to start any analysis, this is the framework I use. I start by importing my data, I tidy the data, I transform, visualize, model, then I communicate whatever findings I have. But as you see here, we have a circular motion, meaning that this is a repetitive task. Yeah. And so we'll go through all this today, and I hope that you just gain something from this. Of course, this is from Adlewika, and yeah, so I use this framework. Now, to the first part, data import. This is the entry point into data analysis. And with importation, what you're trying to do is just bring your data in. So if you see, for example, we have this is the data set that we'll be working on, the Bergera region data set. And right here, we see we have day, month, year, temperature, and all these other variables. But this is how it looks like on spreadsheets. Now that I've imported it into R, this is how it looks like in R. Yeah. Then next is exploratory data analysis. Exploratory data analysis is like a fancy term for people just starting out when it comes to data science or data analytics. They will come across this, but it's not just a step. People do make mistake and think it's a step. It's multiple steps into one. So I think it's from tidy down to model. Yeah. So with exploratory data analysis, what we are doing is we are trying to clean our data, transform it, visualize, then also see how the variables that they have, they correlate one way or the other. Yeah. Now let's go to the second step properly. I just have to bring that up. Now, tidying your data, this involves cleaning your data, actually. And to do that, the way we do that, we firstly confirm the property of the data. We are going to go through all this also. Then we get a quick summary of the data. We try to identify if there are any issues with the data, then we remove or input rows. Then after that, we ensure variables have the right data types. Then we check for outliers. Now, to the very first step. Now, this is the Algeria wildfire data set that we have. And right here, I've just checked a quick property of the data, and you see we have CHR. CHR means character, like alphabets. But yeah, that's the best way that we can relate to it. Now, look at the number of columns we have. We have 14 here. We have 246 rows. But we can see that we have numbers right here. 110, we have 13.5. So these definitely should not be alphabets. There should be numbers. That's to tell us, that's already giving us insight about the things that are already wrong with this data. So ideally, what should be done is you have a scratch pad or you have a notepad next to you and you write the things that are wrong with your data. Like now, the data types are wrong. Then moving on, we get a quick summary. This is just to give us a feel of summary statistics like the mean, median, mode. And of course, we still have these properties coming up that yes, all the variables that we have, the 14 columns, they are all character data types. And right here, we see n missing, which is the number of missing values. And we have from 0, we have only 1 here, and we have 0 here. That means this is having 1. Also, this has tried to just given us, it has given us like some min max values, but this is wrong. Wrong in the sense that there should be more, but since this is a character, it should just minimize everything. Yeah. Then the next step is checking for values that are kind of wrongly placed or do not make sense. Yeah, the things that we feel makes our data wrong, maybe extra row that is wrongly represented or extra columns that should be removed. But right here, I've zoomed this into the row number 122 to 125, right? And you can see this range. We have this right here. This is Sidi Beladis. That's a region in Algeria. And right here we see NA, which means missing value. This NA is missing value. But now if we look at this row 1 to 4, we have day, month, year, temperature, RH, and it's exactly what we have here, which means that the column names or the headers have been repeated again. So these are things that usually happen once we when we handle environmental data. Now, moving on, we need to start treating all these issues one by one, and that's why writing this down would help us. So how this is being treated is, firstly, I've removed the missing data, which is this. Then this row has been removed. Then this row also has been removed, and I did that just filtering this part out. So I use that to remove everything. Then after that, if you notice, the first thing we did was to check the properties. Then we confirmed the data property. We saw that everything was character, and it shouldn't be. So that has been corrected here, and they have been changing to numeric data type. And we have FCT here, which means factor or categorical data. Now that's another important step. Then that's not all, because with environmental data, some of the values we have, they are measured. Some of the values that we'll need, they'll be derived, meaning that we get them from other columns. And this is usually very common, especially when you want to convert from one unit to another, maybe from meter squared to hectare, maybe from Fahrenheit to Celsius. Yeah, so we need to create columns for that. But what I did right here is I just created a column for regions, since we have no identifier for the two different regions which we have on our data set. And also I've used the combination of day, month, and year to create the date column of variable. Well, I'm in the data transformation part of the life cycle, and this involves mainly filtering your data and getting summaries. This part is also actually very powerful, and this is where we get insight. But we've seen how filter works actually, because we saw it in the last place where we just removed just a part, just a single observation or row from our data. Then now to summaries. One quick thing about summaries is this is where we start to get insights. Now, what I've done here is I've counted the classes, which is the occurrence of fire right here. And we see that we have 138, meaning that what fire occurs more than fire not happening. That's what this signifies. Then also, I've counted the region just to see if the data was collected equally across the regions, and I can tell that yes, it's collected equally. Then after that, I'm interested in seeing how the occurrence is in the different region, not in general. And I can see that Sidi Belades is having more wildfire compared to Bejaya. Even Bejaya is having less than having more. It's having 59 compared to 63. And of course, the FWI of Sidi Belades is higher. It's 12.6 compared to what Bejaya. So these are some of the things that data transformation can help to. It gives us insight into our data. Actually started like understanding our data. That is some of the things that we do with data transformation. We can do with visualization because you even understand better, and it also helps your curiosity. So in the next slide, we are going to see actual visualization, but I do have a working plan. When I'm working with data, I focus on the response variable. Then after that, I move on to the explanatory variables, which are the other variables. Then I check the relationship between explanatory and the response variables. That's my working plan anytime I work with a new data or any data in specific. And for this, the response variable, which is the occurrence of fire or no fire, we can see that rightly, of course, here, as we've seen before, that fire occurs more than fire not occurring, and this is in the whole of Algeria. Then once we move on also, we see that, yeah, once we check the distribution of FWI, which is the forest weather index, and this is a continuous data, meaning it is numeric. Yeah, we see this, there are a lot of zeros right here, and we see the shape, we see that it is rightly skewed. And this is already giving us signal that, okay, yeah, maybe we need to perform some type of data transformation if we are going to model this variable. Then for the explanatory variable, because there are usually many, I just combine them as one. And what you're interested in is the relationship between them, just to avoid, just to know the kind of treatment that you are going to do. Maybe you need to do principal component analysis or any form of analysis. All right here, and also to check their distribution. Right here, we see temperature, which is having a normal distribution. We can see the correlation with FM MC, and we see 0.75. So these are some of the things that you'll be interested in when you're working with your data. But now let's move to the response and explanatory data. And we've done this with in the transformation stage, and we see that yes, indeed, CD Belardis is having more fire than no fire compared to what Bejaya. And the interesting thing about this chart is it is beautiful. I don't care what you say, but it's a beautiful chart. But this is not the type of chart that you need for publications, because publications, they do have their own format. Yeah, when it comes to presenting your chart. Then also right here, we've plotted FWI against time just to see how the trend for the forest weather index is. And we see that when it gets to between July to September, there are a lot of spikes. So we should be expecting a lot of occurrence of wildfire around this region. Yeah. Then moving on, yeah, we have still response versus explanatory variable. And this is where it gets further interesting. Now, I've added the classes. We see that right here, lower FWI, they are held down. And what we see is what? No fire. And for the higher ones, we see that what? They are fires. And we can see the numerous spike. We see that August, September have a lot of spike. And this is usually around fall in Algeria. This period is around fall in Algeria. So there's a lot of dry leaves on the floor. And yes, that is a lot of fuel load. So this gives us insight into how we can manage the forest properly in that region. Yeah, but this is not an oversized wish cookie that just answer everything. If we look at this now, we have a low value for FWI, but fire is still happening. Why right here? Fire is not happening and it's pretty dry compared to this. Well, there are some things that I would like us to keep in mind when we visualize our data in general, and we just need to know that we can combine our data to create visuals and send a clear message. In a way, I'm already sending a message with the visuals that you've seen. Then also, it's used for exploration, and it's used to make us curious. I know the thing about curiosity, the more you feel it, the more you understand. And that's what visualization is there for, to help us explore and to understand our data better. But one of the most important things when it comes to visualization is what the possible actions that you need to take, especially moving forward when we want to model the data, which is the next thing that we are going to do. We'll be modeling this environmental data. And for this, there are some factors that we need to consider before we model and before we choose the choice of model. The first is the data type. We have categorical data. That's the forest occurrence, like fire or no fire. That's one. We have continuous or discrete. But for this data, we have no discrete, but we have continuous, which is the FWI, forest weather index. Then the size of data, is it large? Is it small? If it's small, maybe we should use t-test instead of using ANOVA. If it's large, should we use ANOVA, linear regression, or use what more sophisticated models like random forest, XGBoost, and the rest? The linearity of the variables, it's nice to also see how the variables relate to each other. Do they move in similar direction or different direction, or they have no relationship at all? These are also important factors. Then the distribution of each variable. We want to see if they have the bell curve, if they have either the bell shape, if they have different shape, or if they have, like the one we have in FWI, a right skew data or a left skew data. These are all important. By the way, that is called Twiddle. And now, I think the most important of all for why you want to choose a variable is either you want to explain relationship or you want to predict values. People interchange this some of the times, but linear regression, simple linear regression is very, very good when it comes to what's explaining the relationship between variables. Yeah, so we'll be going to simple linear regression. All right, here is this simple formula that I'm used to. Y is the response variable here. YBO is the intercept. All these concepts that will be explained as we use an actual example soon. Then B1 is the slope. Then X is the explanatory variable. Then we have the error 10, which is E. This error term sometimes confuses some people, but this is like invisible. It's just, I'll call it law of nature, something that cannot be explained. Since we're always trying to abstract nature in some kind of way, they have to be error. And that's what this error term means. Now, for a classic example, the most simplest example that I came up with is the relationship between FWI and temperature. That means how the forest weather index relates to temperature. And on modeling that, of course, people have seen this multiple times if they use either R, Excel or SPSS or any tool that they use. And this thing might be some of the things that confuses some people. So I'll try to shed some light on what they mean. And also we have these asterisks. So these are things you should be interested in. The estimates, this asterisk, which shows if there's significant difference or not. Then also the house squared. So starting from the very start, what the intercept means at any point in time is, given that everything is equal, what will be the value of our FWI? So what it's trying to say here is, if temperature is 0, our FWI is minus 30. That's interesting. So we see that indeed we have some type of relationship. And if we want to know the direction of their relationship, you have to go to temperature itself. And you see 1.15. It is positive, meaning an increase in a unit of temperature, an increase in temperature increases the FWI by 1.15. A unit increase in temperature increases FWI by 1.15. So that's the meaning of this. Then the next thing that we're interested in is the R square and the adjusted R square. They're usually very close, not that far apart. And if you see this, we have 0.3213. And what this signifies is how much of the data is the model explaining. And right here, we can see that it's explaining 32%, 32.13 to be specific. And that is not really good. In forestry, you need something that is higher than this to say that the model is reliable. If you are in marketing now, this is good luck. Like, this is a very good model. 0.1 is even the benchmark for marketing, but in forestry, you expect higher than this. 0.7, 0.6, 0.8, not 6, 7, 8 are showing good reliability of the model. But this is too simple. What about if we complicate things a bit? Maybe not complicate. What about if we try to get more relationship a bit by adding other variables? We have temperature, relative humidity, and the rest. And with that, we have this right here. And notice what we have here. Previously, in temperature, there was significant difference. But once other variables have been added, you see that there's no significant difference. Previously, there was a positive relationship, but now that have disappeared to negative. So that's why you always need to add some variables, and not just add some variables, try to understand what is happening as much as possible, and not just go with the first results that you get. Now let's move on. We see that this is having a negative relationship now. When everything is 0, FWI is around 1.5, and that is not bad. So when the relative humidity, wind speed, and the rest is 0, we have 1.56. And if you can check, the only things that had positives to the FWI includes rain, which seems strange. Includes rain, it includes ISI and BUI. But now let's check the multiple R squared. A multiple R squared, we have 0.9753. That is, wow, that's a very good model. But I've always told people that don't let this value of the R square confuse you and think that you have a reliable data. But now let's just go to some assumptions before I come back to explain that. Yeah, so generally, when we want to work with simple linear model, we have to ensure that there is truly a relationship between the variables. Also, we ensure that the variables are independent from one another. Rain does not depend on temperature, especially if you are in a country like the UK. It can be a sunny summer, then suddenly you see snow and you see rain in the same day. A very strange country, I must tell you. Then also normality, just to see how everything is distributed. Is it having the bell shape? Is it inverse? Is it showing a non-linear relationship and things like that? Then this strange term, which always breaks my teeth some of the time, muscidasticity. That's just to show if we have a constant variation and if our points are distributed randomly. We'll see that now. Now, just to interpret what we had before, yeah, I have right here this. I would say we have 0 to minus 15, and this is the residual plot. And for this residual plot, you should notice we have very little positives right here, things that are above 0, very, very little. And we have a value here, 188, that is what? Drawing this and pulling this down. So once we draw the shape of this, we have a fan-like shape. And this is showing that the model, even as it explains a lot of the data, is actually a bad model. Because to see if it's a good model, especially when it comes to simple linear regression, you want these points to be scattered. 0 should be somewhere here, then all the points should be scattered across, and there should not be like this. So now, why it explains a lot, it is not really a good model. So this model, it captures lower values more accurately than higher values, and we can see that here in our residual plot. Then also the potential is showing potential non-linear relationship, and that's why we have this fan-like shape right here, which the points have already shown us. Then just to refresh us to this previous chart which we saw earlier, we have a lot of values that are close to 0. That's why we have these points I. And one thing with zeros is that it generally affects simple linear regressions. It doesn't do well with that. So it indeed needs transformation. FWI needs transformation. So what we do is I'll just summarize then. I'll tell us how we fix that. We should just keep in mind that environmental data in general, they are messy, and exploratory data analysis is your best friend. During our IDEO process, if I followed if I've just simply followed the transformation, even while I've seen that FWI is rightly skewed, it would have saved me a lot of time. Then also, statistical significance does not always mean practical importance, and we saw that also. Yeah, even while we had I/R squared, the use of the model is 0 because it's explaining a lot, but it's not practical enough. Then also, that model is not bad, but it's just help us validate some assumptions. Then to handle models like this, what we need to do is we either log transform FWI or some other values, that's some other variables in the explanatory variables, or we had +1 to FWI just to eliminate all the zeros, or we just change the model. We either use 3D regression or generalized linear model. Yeah, so please, if you do have questions, that's welcome. So please, you can ask your questions. And yeah, if you're interested in things like this, or you want to just know more about how, you can follow also on YouTube at eustudyassist.com. Yeah, that's the end of my presentation. Thank you.
Thank you so much for your wonderful presentation, and